Okay, so now we do the revision for the topic one, which is heating curve. Now for heating curve, the idea of this blue is that there's about 6 questions, 5 to 6 questions for each subtopic. So the first 2 subtopics, you will try to copy the answer, you try to understand how is the answer and what is the proper answer. Then the 3rd question, 4th question, 5th question, you try to do it by yourself. Then after that, then you check the answer. Okay, because if you only like write the answer once, right? Because chemistry normally the marking scheme is very strict. So technically a lot of keywords you have to really write in. So normally you need you to write the same answer for like 3 times, 4 times only. You're able to remember, and maybe the first 2 times you copy, but the other 2 times you have to try to write out. Then maybe wrong, then you know which word, which keywords you're missing, or that. Then from there you do the 2nd round, 3rd round until you're okay. Okay. So now we look at this first question now. Okay, first thing, how to do this kind of question, first thing you have to draw a line here. You have to draw a line here. Then melting is changed from solid into liquid. Then boiling point is the liquid change into gases. So for this question, classify A, B, C, D, E according to the state of matter at room temperature. You have to remember room temperature is 25 Celsius. So in this case, right, you have to check where is 25. Now 25 is more than -101, means already melt, so it becomes liquid already. Then it's more than -35, so means it already boil, so it's already gas. Then the second one is already melt, because higher than 94, but it's not yet boiled because it's lower than 65. So this substance B will be in liquid form. Then for C, it will be more than the 17.8, but less than 290. So it will be a liquid as well. Then this one is less than 97, means not yet melt, so still remain as solid. This one also less than 801, so it still remain as solid. Okay, this is how you try it. Okay, state the substance that would change from liquid to solid. Now, from liquid to solid, you go through the melting point. Okay, melting point and freezing point, they're actually in the same temperature. For example, if water freeze at 0 Celsius, it will melt at 0 Celsius. So melting point and freezing point, they are the same. So when you place into the freezer at 2 Celsius, you see, the idea is this. Before the hidden K-part question, they will hide one of the information. That what information given is before you put into the freezer, the original temperature is 25 Celsius. Then the freezer is 2 Celsius, that means it will from 25 change to 2 Celsius. Okay, because they hide the 25, because before you put into the freezer is 25, means room temperature. Then you start to, when you put inside the freezer, the temperature will start to drop until 2 Celsius. Okay, so means the melting point must be between 25 to 2. So it will be a C. Okay, in order to freeze that, means this thing at 17.8, you start to change from liquid to solid, you freeze to solid. Okay, then describe the change that take place for the particle B relate to the energy and attraction force between the particle when cooled down from 80 to 2. So you check here for substance B, 80 is here, 2 is here, means you go through the boiling point, means you from gas change to liquid. Okay, so for gas change to liquid, what will happen? The kinetic energy will drop, but because for the gas will be higher kinetic energy, liquid will be lesser kinetic energy. Then the force of attraction becomes stronger. Force of attraction try to say stronger, don't say increase. Okay, normally you have to look at these keywords. Then for here, this is carry out experiment to determine the melting point of lauric acid, which is this is the melting point, because melting point is a constant temperature that they from solid turn into liquid. So the middle here is solid plus liquid. So this is the melting point. I will draw properly here, like this. You draw like this, dotted line. Okay, then draw the particle between R and S. Okay, between R and S is liquid state. So liquid you have to draw not orderly arrange, and then they all must connect to each other. You cannot be like separate up. It's all connected because liquid they didn't separate like gases. Okay, unless your water split into two parts. If not, all the particles still connect with each other. Okay, the melting point of lauric acid is 43. Suggest one suitable method to heat up. So 43, we can use water bath to heat up. Okay, draw the apparatus setup. So your school exams sometimes will ask you to draw the apparatus. So this is the apparatus you have to draw. So first thing, remember you must have wire gauze for the heat evenly. Then this boiling tube, we have water bath. Then if the temperature more than 100 Celsius, then you have to change the oil bath. Okay, then after that, the test tube do not touch the beaker. You must remember this one. Then everything in all the apparatus in the you draw, right, must be like have something hold it. Don't hang at the middle of the air like this. Okay, so you need a retort stand to hold it. Okay, so this is the first question. So you go move on to the second question. Second popular question is this one, the heating curve. They'll ask you what is the purpose of the water bath. Now, so for water bath, the idea is this. Okay, if we heat directly, here will be very hot, but above is cold. So what we need to do is we will try to heat the water first. Then the water will start to heat uniformly like this. Okay. Then second one, if directly impose the fire to the naphthalene, it might be what we call the flammable, means it might caught fire because naphthalene is flammable substance. Then these two main reasons. The water bath is to make sure the heating is uniform. Then after that, make sure it won't like the naphthalene won't caught fire because the maximum temperature of water is only 100. It won't be so hot. Okay, then why we need to stir the naphthalene? Imagine now I'm heating this thing. Normally, the side will be hot. Then the middle here will be slightly cold. So if you don't stir what we call the naphthalene, right, the temperature won't be same. So we need to stir it so that the temperature for the whole naphthalene is the same. So it's to ensure the temperature are uniform, not like just at the side is cold, at the side is hot, then at the middle is slightly lower temperature. Then this is the question always asked in exam, standard. They will say why the temperature remain the same. Means when you're doing melting, right, your temperature will suddenly stop here. They'll ask you why temperature constant here. So you mentioned this answer. The heat absorbed by the particle is used to overcome the force of attraction between particles so that the solid turn to liquid. You have to remember this answer. So it means they actually try to separate all the particles so that it becomes liquid state. Okay, then sulfur has a melting point of 114. Can the melting point of sulfur determined by using water bath? The answer is no, because the maximum temperature of water is only 100. So the melting point is 114. So you weren't able to use water to heat the sulfur until 114 Celsius. Okay, sketch the heating curve. The heating curve of the naphthalene when the temperature is the melting point is 80 Celsius. So this is how you sketch it. Okay, first dimension here is temperature. And remember to write the unit. This is time. So this is maybe per minute. So this is the temperature going up. So let's say you start with 25. Then you will start at 80 and go up here. So here is 80. Okay, so this is the idea. Then besides, the diagram besides shows the cooling process of naphthalene. So what's the use of conical flask is to make sure, it's similar to the water bath, is to make sure it cool down uniformly. So while you stir slowly, it's the same. You'll make sure the temperature is uniform. Then This one will always either ask you why the temperature will remain the same during heating or why the temperature remain the same during cooling. So this is another answer. So you have to have all this answer. The heat loss to surrounding is exactly balanced by the heat release as the particle attract one another to form a solid. So you see, the heat loss to surrounding, okay, is balanced by the heat release, because just now from solid to liquid, okay, it absorb heat to try to overcome them, absorb heat. Then terbalik, you release heat. So when liquid change into solid, right, it release heat. This heat will same with the heat loss. That's why the temperature remain the same. Okay, so then they would like to ask you to draw the diagram. Same thing. Cooling curve. Then temperature. Time going down. Stop at 80. Going down to here. Let's say drop to 25. You start at 80 Celsius again. So this is the graph. Then, okay, for this one, you can try, okay, now you can try this question by yourself. Then after that, you can check the answer. So here is solid, here is liquid, here is gas. Then here is solid plus liquid, here is liquid plus gas. Okay, physical state for PQ. PQ is solid. Then QR, you have to write mixture of solid and liquid. Okay, solid plus liquid is cannot. Solid and liquid cannot, must be right mixture of solid and liquid. And then T and U is gas. Okay, when it begin to boil, boiling is now boiling is from liquid change to gas. So this is the boiling point. Then begin to boil will be my T3 minutes. Okay, then after that, what is the melting point? Melting point is from solid turn into liquid. So this is your melting point, 115 Celsius. Same lah. Why temperature remain constant? So same with previous questions. The heat absorbed is used to overcome the force of attraction between the particle so that the solid turn into a liquid. Then sketch a graph. So they always give you heating curve and then ask you to draw the cooling curve. It will be exactly the same, but just the graph. You still stop at 445. You still stop at 115. That is. Okay, so suggest the physical state for the substance. You can try this by yourself. That room temperature is 25, and then try to find the location of 25. So 25 is here. So this is solid, this is liquid, this is gas. 25 is here, 25 is here. So one is solid, one is liquid, one is gas. Physical state, if R heated to 1000 Celsius, we check R 1000 is here. So it's liquid state. Okay, then you try the next one. A compound in vapor means gas state is cooled down from 300 Celsius to room temperature. So you can see this is gas state, this is liquid, this is solid. So this is gas and liquid, this is liquid plus solid. So freezing point, this one you have to know the definition. It's a constant temperature. It means this temperature no change one. Okay, constant temperature, which a liquid turn into solid at a specific pressure. You mention at the specific pressure because different pressure, the boiling point and melting point will change as well. Okay, so what is the freezing point? Freezing point is from liquid change to solid, it will be 80 Celsius. Then same thing, why remain unchanged? So same like the heat loss of surrounding, same with the heat release when the force of attraction form between the particles so that the gas turn into liquid. So the answer you need to write in this format. Okay, this answer is very important. They mark very strict in exam. So make sure everything here you write properly. Okay, then what's the physical state from T2 to T3? Let me check. D2 to T3 is liquid state. T4 to T5 is liquid plus solid. So it's a mixture also. Must mention mixture, these words are. Then two box to draw out T0 to T1. So 0 to T1 is gas state. Then after T4 is solid state. So you need to draw a gas and a solid. Then sketch a graph against is terbalik. So this is the graph. How does the graph looks like? Your constant here, your constant here. Same temperature. Okay, it's just reverse the temperature. Reverse the graph really. Okay, this is the slightly K-but questions. We go through here. State the temperature change from solid to liquid. We check here. This is solid. This is liquid. This is gas. So solid plus liquid. Liquid plus gas. So the temperature for solid to liquid will be here. So you have to check the temperature here. Then you read the temperature. Okay, it's about 80 Celsius. Then liquid to gas, then you check the temperature here. Then you read the temperature. It's about 240. What happened to the temperature when change state? So when change state, the temperature will remain because the heat absorbed is used to overcome the particle. You can see this explanation keep coming up in every question. So, and the answer you see is fixed one. So you cannot like missing some keywords. To make sure you need to remember this one. Draw the particle for T1 and T, when T is 3 minutes, 5 minutes and 30 minutes. Check here. At 5 minutes, right, it will be solid plus liquid. At 30 minutes, right, it will be liquid plus gas. So how do you draw this kind of thing? Is looks like this. Here you can see here is solid, here is liquid. It's melting now. Here is liquid, here is gas. This is what we call mixture. This is what we call mixture. Okay. Is this substance water or not? Now, water, you look at here, 80, melt at 80, boil at 240, definitely is not water. Okay, then go for the F. Okay, for sublimation, there are 4 chemicals will be sublimating. You have to remember this one. First, dry ice. It will from solid immediate become gas. Iodine also same thing. It will immediately from purplish black solid turn into purple vapor. Ammonium chloride will also same thing. If you heat, it become gases. From gases, it will become white film. Means it become back your solid. Then naphthalene also same thing. If you heat, it will also become gas. It will slowly become gas. If you heat, it melt. But when it what we call you put it there, you slowly straight become gases without become liquid lah. Then after that, for this one, type of particle formed in iodine. Iodine is a molecule because iodine is I2. Then in the process that take place, you can see here, iodine you heat then become solid here. So it's a sublimation. What is substance X? Now here is impure iodine. This is a K-but question now. Impure iodine, right, it might have other substance, but this other substance, let's say example, I have iodine inside plus another chemical A. But when I heat, right, this thing will become gas, iodine will become gas, but this one will become liquid if we reach the melting point now. So only iodine will evaporate, then go to here, then deposition again become solid. So your X is only pure iodine. Because the impurity, it won't become gas. Okay, so it's a deposition. If I only heat up, what is the change of the distance? Of course, will increase because it become gas. Then kinetic energy increase, attraction force become weaker. Remember, force you cannot write increase or decrease, must write weaker or stronger. Okay, so when it's heated, it will be from solid turn to liquid form.